Okay, video 4.2b as in boy, the elimination method. Continuing on, we're ready for example number 3 here. So let me get rid of my number there, and let's put number 3 in there. 2x minus y equals 6, x plus 3y equals 3. All right, so again, if we add these, notice what happens. 2x plus x is 3x. That doesn't go away. Negative y plus 3y is 2y. That doesn't go away. So if we just add these two, because they're not the same number in front of the x's, nor are they the same number in front of the 3, we can't eliminate the x or the y as they are. So we have to find another method. All right, so let's look. One of the things we said was we're going to try to eliminate the letter that is the simplest. Well, let's look at the x's. I have a 2 in front of the x here and nothing in front of that. So a number and nothing. Here I have nothing, no number in front of the y, and I have a 3 in front. So neither one of these one is not easier than the other. But if you remember, when you're adding these, not only does this number and this number have to be the same, but the signs have to be opposite so that they cancel. So if this was like a negative 2, then when we add these, they become 0 and the x's go away. So that's another thing that we're looking at. Do we not only have the same number in front of the x, but do we also have opposite signs so that they cancel? Okay, so this one we not only don't have the same number in front, but we also don't have different signs. We have a positive 2 and a positive 1. Here we don't have the same number, but we have a negative and a positive. So that means we're going to change this one. Now again, it doesn't matter which one you try to get rid of, but you're just trying to save some time. So same number in front of the variable and opposite signs. So we have neither here. This one, at least we have opposite signs here. So what do I need in front of this 3 in order for this to cancel with this? Well, if this were a negative 3 plus a positive 3, those would go away. So I'm going to make that a negative, or I'm going to make this a 3 right here. And then it'll be minus 3, and that'll be what I want. So how do I make that a 3? Well, I put a parenthesis around the entire thing and distribute that 3. Okay? So this becomes 6x minus 3y equals 18. Don't forget to multiply it by the end number as well. Now I have x plus 3y equals 3. Now what happens if I add them? Those go away. Okay, then I divide by 7, and my x equals 3. So I was able to find out what my x is. Now I go back to the original problem. This one looks like it might be easier to substitute that 3 in. So I put a 3 in for x, subtract 3, so I have 3y equals 0. Divide by 3, y equals 0. So when x is 3, y equals 0, and then again it's written 3, 0 in that order. X first and then the y. Okay, now, again, a way to check that is to take your answer and put it in for one of those problems. 3, then I'm going to do the bottom one. Oops. And then I'm going to do the top one, see what we get there. 2 times my x is 3 minus y. What is y? 0. Equals 6. So 6 minus 0 equals 6. So that one works too. So they both work. This answer works for both of them. So that means we did it right. Okay, let's look at example 4. And like I say, these get progressively more complicated. And hopefully you won't have too many struggles with them. But this is really important information. As you continue on with math, you will continue to do these. I mean, these will not go away. This is part of algebra. So even when you get up into higher level math like college algebra, you'll still do them. All right, so what do we have here? We're going to add these two. Now again, notice what happens here. If I add these two, I get 5. I add these two, I get 9. So nothing disappears. So now I have to make sure that they disappear. So in the last problem we did, if we had something like a 2x plus y equals 10 and a negative 1x minus 3y equals 14, remember what we did? We just multiplied this entire thing by 2, and then that turned this into negative 2x minus 6y equals 14. And that way we could take our positive 2x plus negative 2 and my x's would disappear. Now if you notice over here we can't do that. I can't multiply a 2 by something and get a 3 so that I can add those together and get 0. I can't multiply a 4 times something to get 5 so that when I add those I get a 0. So I've got to figure out a way to get these numbers to be the same, either the 2 and the 3 to be the same or the 4 and the 5 to be the same. And not only do I want them to be the same number, I want them to be in opposite signs. All right, that is not possible. Just to multiply this whole thing by any number and get 3, not going to happen. So what I end up doing is I have to, again, look at the simplest one. Is the x's simpler or the y's? Well, here I have two numbers in front of the x's and the signs are the same. So I've got two strikes. I want both the numbers the same and the signs to be different, and I don't have either. Numbers are different, signs are the same, so I don't have either there. So then it doesn't matter. Both are just as hard as the other. So what I'm going to do is I'm going to look at the x, just because they're smaller numbers, not for any particular reason except for that. This has a 4 and a 5, this has a 2 and a 3, so I'm going to use the 2 and the 3. So if I can't get the 2 to be a 3 or the 3 to be a 2, what if I found a number that was common to both 2 and the 3 and changed it to that? What if I tried to turn these two into 6's? How would I do that? Well, if I multiply this by 3, then 3 times 2 would give me 6, right? And then I would just multiply that and that. If I multiplied this bottom one by negative 2, when I multiply these together, I get negative 6. Okay, and they multiply that and multiply that. So let's do that distribution so you can see what I have. Okay, so in red, the top number distributed, 6x plus 12y equals negative 3. And in blue on the bottom, negative 6x minus 10y equals negative 2 times negative 2 is positive 4. Now look what I got here. I've got the same number, and they're opposite in signs because I chose to multiply this one. I needed this bottom one to be a negative, so I multiplied it by negative 2. I mean, if I multiplied it by a positive 2, I would have gotten a 6, but I wanted a negative. I wanted the signs opposite, so now I have the numbers in front of the x's that are the same and the signs that are the opposite. Okay, so let's add those. We add those up, and those go away. We add these up, and we get 2y. Negative 3 plus 4 is 1. So divide by 2, and my y equals 1/2. Okay, so I did get an answer. It was 1/2. It wasn't a real fun answer, but I did get it. Okay, now all I have to do is take that 1/2 and plug it into one of these original equations. So let's do that. 2x plus 4 times 1/2 equals negative 1. 2x plus, what's 1/2 of 4? 2. Subtract 2 from both sides. Divide by 2. That goes away. So x equals negative 3/2 when y equals 1/2. And then it can be written this way. And that's how I would prefer it written, negative 3/2, 1/2. Okay? So you're feeling like you're seeing what's going on here? Notice that if we were to have graphed this, graph this line and then graph this line where they cross, we probably wouldn't have figured that out, because that, being a fraction, is a lot harder to figure out than if it's a whole number. So this is why we use elimination, because it's a lot more accurate. Alright, so let's keep going. Let's look at example number 5. Okay, so here's example 5, and we want to add those two. Okay, problem is, again, numbers in front of the x's and the y's are not the same, nor are they opposite in sign. So I can't do anything yet. So I can either make the 3 and the 5 the same number or the 4 and the 5 the same number. It doesn't matter which one you choose. You will still get the same answer. So because the 3 and the 5 are smaller numbers than the 4 and the 5, let's find a number that both a 3 and a 5 will go into. Well, both 3 and 5, the smallest number they'll both go into is 15. So I'm going to make this a positive 15 and this a negative 15, so that when I add those, the x's go away. So in order to make that 3 a 15, I multiply it by 5. In order to make that 5 a 15, I multiply it by a negative 3, so it's a negative. Okay, so top number, 5 times 3x, 5 times 5y, 5 times 2. Bottom number, negative 3 times 5, negative 3 times 4, negative 3 times 1. Now I draw my line. Now I can add them because the number in front of the x is the same, and one of them's negative, one of them's positive. So what do I get? Those go away. This becomes 13y. This becomes 7. I divide by 13, and my y then is 7 over 13. Alright, and then this is, that was the hard part really. Now I take my equation, doesn't matter which one, and I plug 7/13 in for y. So 3x plus yuck. Okay, I'm going to subtract 35/13 from both sides. And I have to find common denominators so I can actually subtract those. So I want a 13 there, so 26/13 minus 35/13, still looking at yuck. 26 minus 35 is negative 9/13. Okay, so far it's still looking pretty nasty. Alright, so we divide by 3, and I'll go over here to the left. X equals negative 9/13 times 1 over 3, because remember, when you divide, you invert and multiply. So x equals negative 9 over 39, which, if you were to try to reduce that, 3 goes into 9 3 times, 3 goes into 39 13 times. So when y is 7/13, x is negative 3 over 13. So if we were to erase all this and just put an answer down now that we've figured all that out, we would get negative 3 over 13, 7 over 13. And that would be my answer then for example number 5. Alright, new video, and we'll go with example number 6.